Let's put a motor together. Welcome back to the shop. You can see I've got my motor bits ready. They all got painted recently. Nice satin black color. Here's a quick shot of spraying that. You can see I'm using an aerosol can. There aren't really a lot of good options as far as like ceramic engine paint that come in something that you can put into a spray gun. And honestly, the results with this VHT stuff look great, so no real worries there. The important thing is you gotta bake the paint to cure it. All right, I'm not gonna bore you guys with too much explanation today. I'm just gonna get right into it. First thing I need to do, remove that old bearing. Made my way over to the motor workshop in order to use the oven there. We're gonna throw this block in there, get it up to 250 degrees, and then I have assembled all of the parts and pieces to make a little press to get that bearing out. Back in the shop. So I did manage to get my two bearings out of the case, the bearing carrier. I ended up having to go all the way up to 350 degrees Fahrenheit in order to get it out of the block. 250 degrees, which is what's stated in the manual. The bearing just wasn't budging, so up the temperature went. Eventually, I got it to start to move, and then it came out pretty easily. So for the front bearing carrier, I just did the same thing, 350, came right out. Just like removing those main bush bearings, installing them is also going to require a lot of heat, and the bearings themselves are going to be stuck in the freezer until right before we're ready to use them. There's a piece of steel that's going to sit flush with the inside of the bearing surface. That way, when I go to press the new one in, it's going to stop exactly where it needs to. Furthermore, I am going to make a new little tool. Here's my old bearing. You can see that this circle is going to be slightly larger and this one slightly smaller. I'll stack the two pieces, that way the smaller one goes inside the bearing and the other goes on top. That is going to ensure that they go down nice and straight. Just finished up on the lathe. You can see I've got the two parts bolted together, and there's an old bearing. As you can see, that fits pretty nice. So that'll ensure that this goes in nice and even. You can see I've got two little counterpunch marks right there. I'm going to put a couple holes in here just to bolt this piece to this piece so that this one doesn't drop. And then I think we'll be ready to drop it in. Let me show you what I've come up with as far as an installation tool for this main bearing. We have a piece of M10 metric all thread here that goes through the block. This little piece of aluminum is just to keep the end centered here. Obviously it's very thin, so it doesn't actually provide any support this way, but I don't need it. There's also, I don't know if you'll be able to see, but a little bent piece of metal there. And that's just to, again, keep this thing in the center. And if you look in here, you'll see that large piece of steel. It has two recesses in it. You can see the piece of steel here that is suspended by a nut on the underside. And you can see a little bit of those notches that I cut to avoid the two pins here and here, which stick through to the other side. That's what holds the thrust washers in place, and that's what determines your crankshaft end play. So it's super important that those don't get damaged when you go to press this bearing in. So, a little piece of all thread sticking up here. Bearing, that's no good. What you want to do is find the split. Looks like that. Little puzzle piece kind of thing. That's going to go 26 degrees from vertical. You can see I have that marked out right there. Now imagine this engine block was at 350 degrees or whatever, and this was frozen. I would drop this into place, Then this part that I made goes on next. And that keeps that nice and centered and upright. Finally, put a bolt on. Press it in place with a socket wrench. So the rear bearing's in. Now it's time for the front, which sits in its own separate aluminum carrier thing that gets placed onto the front of the crankshaft. If you haven't watched the disassembly video for the motor, I showed that in pretty good detail, but I have it here in the drill press. Normally what happens is when the bearing goes in, a pin gets peened into place here, and these pins have a tendency to back out on the later motors. I don't know about 75, but I'm not going to risk it. So what I'm doing instead is I'm drilling it out and tapping it for a bolt, which can be Loctited into place. The very tip of the bolt is going to go into the bearing material. So here's my bolt. I chucked it up in the lathe and turned down the end there. Again, this is the Harbor Freight little toy lathe thing that I used. I'm not going to show you it to you because it's embarrassing. So I'm going to shorten this up by a little bit. I know the thickness of my bearing that you can see here. This is one of the old ones. I can measure that thickness. I can measure the thickness of the bearing and make sure that this little nub doesn't exceed that. Okay, so you just watch me drill and tap that hole. Here I've got an M5 bolt in there. What I need to do now is remove some of this material, grind that threading off, and figure out exactly how long this needs to be so that when the bearing goes in, that it's not going to contact the crankshaft. I'm ready to prepare to drop this bearing in. So first things first, I'm gonna pop this carrier in the toaster oven, since that's what I have here. Bring it up to about 300 degrees or so. Well, here it is, bearing in place. You can see the bolt comes about halfway through the bearing material, right there. And that'll keep it from rotating around and it won't back out. I'm going to drill 2 more holes for the oil passages. Okay, got our crankshaft in, as you can see in there. Torqued down the front bearing carrier, and I put this thing on, which will keep the crankshaft from moving forward. Blocking the crankshaft off is important because if that thrust washer falls off, it's going to be a bad day for your crankshaft. So let's flip this over and then we'll start getting the flywheel on. You might be wondering, why not put the oil pump and camshaft in? If you're putting the flywheel on, aren't you going to need that stuff in there? Like, you won't be able to get at the oil pump with the flywheel on. And you're right. But the reason that we're doing this now is we want to measure that end play. And if you put the camshaft on and the oil pump in and everything, and then you find out that you have to change out one of the thrust washers, especially the inside one, and that all has to come back out. So we're doing it now. That way, in case I do need to make any changes, I don't need to undo a whole lot of unnecessary work. All right, I missed doing the flywheel, but really all I did there was heat it up a little bit around where the bolts connect and then stick it on. Not that exciting.
A lot of shoes before you're actually doing it. Gradually grinding off the sole.
And a whole 10,000 hours deal.
Kind of, yeah. I mean, you know, like, but also one of the things that my guitar teacher really was into was like the jump from thing to thing.
Yeah.
And so he'll come over and
So we've gotten pretty far along in putting together the bottom end on this motor. But I ran into a little snag. It seems that I ordered the incorrect oil pump inner rotor. So there's my part, the oil inner rotor. This spins around and the oil rotor outer also spins around. That generates the force that drives the oil through the motor. Unfortunately, you can see that it's got these two flats on that inner circle there. And that's what keeps it rotating on the camshaft, or, you know, in position with the camshaft. And my motor isn't designed that way. The camshaft has a Woodruff key that goes into a slot in the inner rotor. So unfortunately, I got a part for a later era Airhead. No big deal, mistakes happen. I ordered the correct part and made sure that it's going to get here quick. Thing is, I need that oil pump in place before I can tighten down the flywheel. Can't really move forward until that happens. You can see I have the timing chain on, and I wanted to put the tensioner in, which would normally go right here, but that's going to interfere with this block, and that block is holding the crankshaft in place. If I take that off without the flywheel being in there, the whole crankshaft can move forward, and that thrust washer can come off the pins, and then I'm in a whole world of hurt. So, engine build on pause. I've got the lower end complete. I feel pretty good about that. Next time you guys see that motor, hopefully I'll have the frame back and we can drop it in after I get the front timing cover on. That way we can put together the top end in the bike. It's a lot easier to do it that way because the engine is like half the weight, so it's a lot easier to drop into the frame. Anyway, thanks for coming along. I know that this is a little anticlimactic, but that's a project for you. It's a work in progress. Anyway, I'll see you guys next time.